Okay, so example 2, we're going to now graph an absolute value function of the form f of x equals x squared plus bx plus c. That means we want the absolute value of a quadratic. Okay, so we're going to take a look at the absolute value function of f of x equals x squared minus 4. The related function is y equals x squared minus 4. So we're going to get our x-intercepts and vertex of y equals x squared minus 4. Alright, so let's start with the vertex because that's fairly basic. Alright, remember we have this in the form of y equals a times x minus p squared plus q. Okay, and if we put this in that form, we're going to get y equals a is 1, so we don't have to worry about that. And then x minus 0 squared minus 4. And so we have a vertex which is at 0 and negative 4. Okay, recall x-intercepts occur when y is equal to 0, so we're going to plug in 0 for y. We are going to solve for x, so we're going to move the negative 4 over. We get 4 equals x squared. Square root both sides, and don't forget to put plus and minus 2. Okay, so we're going to sketch this graph in. Our vertex is at 0 and negative 4. We have x-intercepts at 2 and negative 2. And because this is not our absolute value graph, we are going to sketch in the parabola with a dotted line. So this is y is equal to x squared minus 4. Okay, so we're going to use this graph to graph y equals the absolute value of x squared minus 4. Okay, and since there are no negative y's in y is equal to x squared minus 4, you will flip the negative part of the parabola, okay, over the x-axis. Okay, so which part is negative? Well, that is any part which is below the x-axis. We want to flip that over the x-axis. So that means we want to take our vertex, which is at 0 and negative 4, and we want to move it the same number of units above the x-axis. So that's going to take us to 0 and 4. Okay, we keep our x-intercepts. We're going to keep the part of the graph which is above the x-axis. Okay, so all we're doing is flipping the part that's below above. So we will draw that in now because this is the graph that we want. Okay, remember a nice curved line because this is a parabola, and then a nice curved line here, and so you get this blue graph, which is y is equal to the absolute value of x squared minus 4. Okay, so let's take a look at invariant points here. Okay, in other words, which points did not move? Okay, well, our x-intercepts didn't move, so x equals 2 and x equals negative 2. And then everything which is to the right of 2, so greater than 2, and everything which is to the left of negative 2, so that means less than negative 2. Okay, and you can combine these. By writing x is greater than and equal to 2, and x is less than or equal to negative 2. Okay, so that's where your invariant points are. Now, if you take a look, we're going to compare domain and range, okay, for these functions. So of our original parabola, okay, that was the one that I drew in green, all right, our domain is all reals. Why don't I do this in green? All right, and our range, okay, well that's everything above where y is equal to -4. So we say y is greater than or equal to -4. All right, and then let's do the domain and range for our absolute value function. We'll do that in blue. Okay, now if you take a look at the graph, you have all values for x which are less than 0, and you have all values for x which are greater than 0, because the graph is going to move off to the right and off to the left, okay, and everything in between here also. All right, so the domain then is going to be all reals. And your range, well, take a look at what the bottom part of your graph is, okay, the bottom of the blue graph. What's the lowest points, or the lowest point? Well, it's going to be where x-intercepts are, right? So at 2 and 0, and at -2 and 0. So what's our y value at that point? 0. So our range is going to be y is greater than or equal to 0. Okay, so now we're going to write our piecewise function. All right, we're going to keep in mind that by definition, we get this. All right, so we're going to say, all right, y equals our original function, our quadratic is x squared minus 4. Okay, and now we want to write in our domain restriction, right? So so we go back up to our graph, and we say, okay, well, which part of the graph is the original x squared minus 4? Okay, well, the original x minus 4 is along here and along here. Okay, so where is our domain for that? Well, everything to the right of 2 and everything to the left of -2. So when we write the domain for the part of our graph which is y equals x squared minus 4, we want everything to the right of 2 and everything to the left of -2. Okay, so how do we write that? Well, we say that x is less than or equal to -2, or x is greater than or equal to 2. Okay, so the second half of our piecewise function is the negative form of this. So we go minus, and then in a bracket, x squared minus 4. Okay, now what is the domain restriction for that? Well, we go back up to the graph, and we say, okay, well, that is this part of the graph, right? Okay, and where's our domain for that? Well, everything in between -2 and 2. Okay, so we say everything in between. So we remember what we did at the beginning of the year. We put the smallest value first, less than, put the variable we're considering in the middle, which is x, and then less than, and 2. So that means all x values between -2 and 2. We don't want to put less than and equal to, because we've already put the equal to symbols on our first piecewise function. Okay? All right, and so we're done.